Hello students, today we got practice problems for section 11.3 where we're working with limited reactants. Number 9, we had ammonia, very common product produced in the United States, chemical, used to make fertilizer or other products, and it's produced by the given reaction. And they give us how much nitrogen we start with, how much hydrogen we start with. And we want to figure out the limiting reactant. So we start, I'm going to change the 1.00 times 10 to the third. I'm just going to think of that as 1,000. So this can be 1,000 grams, and this one can be 2,500 grams. Then we just go through a little bit of stoichiometry. And we start with 1,000 grams of the N2. And from our chemical equation, not for chemical equation yet, first we need to change that to moles. And 1 mole of N2 is 28.014 grams of N2. Looking at the periodic table, finding nitrogen, doubling it because it's N2, one of our diatomic elements. Then we use our mole ratio, and our chemical equation tells us for every 1 mole of N2, we have 2 moles of the ammonia. And the moles of N2 cancel the moles of N2, grams of N2 cancel the grams of N2, and then 1 mole of ammonia is, figured out its molar mass, 17.0307 grams of ammonia. Moles of ammonia cancel moles of ammonia. Go through our multiplication and division. And we find that we have 1,216 grams of ammonia. And we repeat the process. We'll start with the hydrogen. We got 2,500 grams of hydrogen. 1 mole of hydrogen gas is 2.0158 grams of hydrogen gas. Grams divide out grams. And our mole ratio from the chemical equation tells us we got 3 moles of hydrogen for every 2 moles of ammonia. Moles of hydrogen divide out to moles of hydrogen. And then we have, switch it back to grams, 1 mole of ammonia is 17.0307 grams of ammonia. Moles of ammonia divide out moles of ammonia. Go through and do all of our calculations. And this time we get 14,081 grams of ammonia. One that is smaller is going to be our limiting reactant. It says which is the limiting reactant. So the limiting reactant is nitrogen. On B, we're ask how many grams of ammonia can be produced from the limiting reactant available. And from preceding work we did on the preceding slide, we had from the nitrogen, we figured out we had 1,216 grams of ammonia being produced, which is too many sig figs. We should only keep 3, so we'll round it to 1,220 grams of ammonia. In part C, we want to calculate the mass of the excess reactant after reaction is complete. Here, we just start with you can either start with 1,220 grams of ammonia, or you can start with 1,000 grams of nitrogen, the limiting reactant. Doesn't matter which one you start with, you'll end up getting the same answer. There, I'll go through both of them. You should have only done one of them. So, got the ammonia, so we switch it to grams, 17.0307 grams of ammonia and 1 mole of ammonia. Use your mole ratio. 3 moles of hydrogen for every 2 moles of ammonia. And then switch that. Now let's go back and cancel a few things. Moles. And 1 mole of hydrogen is 2.0158 grams of hydrogen. Moles cancel moles. And on the other one, we would have done 1,000 grams of nitrogen. Want to get it? Figured out how much hydrogen matches up with it. And 1 mole of nitrogen is 28.014014 grams of nitrogen. Grams divide out grams. Mole conversion. We got 3 moles of hydrogen for every 1 mole of nitrogen. Moles divide out moles. And 1 mole of hydrogen is 2.0158 grams of hydrogen. Moles divide out moles. Then we go through and do our calculations. And we find out in both cases we get 216 grams of hydrogen. 216 grams of hydrogen. So it didn't matter which one we started with. Only start with one of your limiting reactant that was given to you, or what you figured out as the result from the limiting reactant. Either one works. Now, what we wanted to know, though, was the question says how much remains. So we use 216 grams. So we go back to we started with 2,500 grams and only used 216 of it. So that means we have a lot left over, 2,280 grams of hydrogen left over. Number 10. Here we got aluminum reacting with chlorine to produce aluminum chloride. Got 4 parts to this one. First part, they just want us to balance the equation. So looking at this, I'm going to I'll write the whole routine out this time. We've got Al and Cl. Hopefully you can do this maybe without quite writing as much out as I'm going to do here. We started with 2 chlorines, 1 aluminum, and we ended up with 1 aluminum and 3 chlorines. So not balanced. So get the chlorine balanced. I put a 3 here and a 2 over here. That would make both of these 6. And that then also changes this to a 2, and I put that 3 in the wrong place. Go fix that. Three is not supposed to be there. 3 is supposed to be here. And then that changes our aluminum, and the aluminum needs a 2 to balance it out. So our equation is 2Al solid plus 3Cl2 gas yields 2AlCl3 solid. So now we got our balanced chemical equation. With any stoichiometry problem, you must always start with a balanced chemical equation. Part B, we're taking this equation, and I'll put our coefficients in up here. We had a 2, 3, and a 2. It says we'll begin with 3.2 grams of aluminum, 5.4 grams of chlorine. Which one's the limiting reactant? So we'll do stoichiometry on both of them again. 3.2 grams of Al, 1 mole of Al, got to change it to grams, or change it to moles. 1 mole of Al is 26.982 grams of aluminum. Grams, divide out grams. Go to our mole ratio, and for every 2 moles of aluminum chloride, we use 2 moles of aluminum. Moles divide out moles. Could also divide out to 2s. And then get back to grams. 1 mole of AlCl3 is 133.341 grams of AlCl3. Now remember, you can have a little different number of sig figs when you figure the molar mass. And then the moles cancel the moles. And when we get all our calculations done, we end up with 15.8 grams of AlCl3. I go back and repeat the process, this time starting with 5.4 grams of the chlorine, Cl2, one of our diatomic molecules. One mole of Cl2 is about 70.906 grams of Cl2. And the grams divide out to grams in our mole ratio from our chemical equation. Every 3 moles of Cl2, we get 2 moles AlCl3. Cl3. Then we get to change the moles. Well, the moles cancel the moles. Now we convert from 1 mole of AlCl3 into 133.347 grams of AlCl3, and do a multiplying and dividing, and we end up with the same thing we had we end up with 6.77 grams of AlCl3. Smaller one is our limiting reactant. So that means that Cl2 is the limiting reactant. Part B, you want to know how many grams of aluminum chloride can be produced from the limiting reactant available. And that's what we just figured out. Chlorine was shown on the preceding slide to produce 6.77 grams AlCl2, but we should only keep 2 sig figs, so we'll round that to 6.8 grams AlCl2. And then D, calculate the mass of the excess reactant. So we could either start with the result, 6.8, you can start with the 6.8 grams of Cl2, or the 6.8 grams of, not Cl2, of AlCl3, and the 5.4 is grams of Cl2. And this is one I'm going to do. Again, like on the preceding problem, either one will work. If you want to check and make sure everything's right, you could always do both of them, and if they turn out to be the same, you can be pretty certain everything's correct. So first thing we do is going to change it to grams. And 1 mole of Cl2 gives us 70.906 grams of Cl2. Mole conversion, 2 moles of Al is the same as 3 moles of Cl2. And we're trying to find how much of the excess reactant we use, so we're switching to Al. Moles divide out moles, grams divide out grams. And I'm running out of room. We'll come down here for a continuation. Now we want to change from 1 mole of Al. Then our molar mass is 26.982 grams of Al. Moles cancel moles. We do all of our multiplying and dividing, and that results in 1.4 grams of Al used. We started with 3.2 grams of Al is what we started with. So we subtract those, and we got 1.8 grams of aluminum left over. So a little bit of work on limiting reactants with what we've done in class, and we'll probably continue to be doing it in class. And this, hopefully by now you have a very good handle on this, but you need to know how to do this. So Make sure you understand it. Got any questions, make sure you ask me. That's all for now. Till next time, this is Strike.